Hi everyone, welcome to Starting from Zero. In the last video, we have a detailed discussion on kinematic analysis of the single slide diagram mechanism. In this video, we are going to see the dynamic analysis of the single slide diagram mechanism. So basically in this chapter, we have to find the different forces which is acting on a single slide diagram mechanism. So first of all, here F is a crank force which is acting on the piston from the cylinder side, from this side. Fn, so Fn is the thrust on the cylinder wall, what is the, or you can say the normal force or the thrust which is acting on the cylinder wall. Now Fc is the force on the connecting rod. Now Ft is the crank effort, and Fr is the radial force. So these are all the force we have to find. In this chapter we will be simply asked to find the different forces. So first of all, if we see, we have to only find we have to only know that how to find the piston effort. See, if we know this angle, if we know the procedure for finding piston effort, and if we know the value of this, then all the other forces we can find by simply applying the geometry. For example, if we know this A piston effort, then if you are asked to find Fc, what you can do, we know that Fc cos beta, this angle is beta, so if we resolve this in cos component, so Fc cos beta will be simply equals to F. So from there, if we know the value of F, we can find Fc, right? So similarly, if we are asked to find Fr, so what you can do, this angle is beta and this is theta, so by geometry this will be theta plus beta. Okay, as this angle will be 180 minus theta plus beta, so this angle will be theta plus beta. So if you know this angle, and you are asked to find Fr, so from here we can find Fc, and if you know Fc, so we can extend this angle, so this will also be Fc. Now Fc cos theta plus beta will be Fr, from there we can find Fr. And if you are asked to find Ft, what you can do, you can simply resolve this Fc into sine component, like Fc sine theta plus beta will be Ft, and from there you can find Ft. Okay, so we will all see all the formulas. So first of all, if we want to find the piston effort, this is the only formula or only procedure you have to remember, that is the piston effort F. So for finding piston effort, we have to the formula is F equals to F gas force of gas minus Fi inertia force minus friction force. Okay, so how we can find F of gas? F of gas is nothing but P1A1 minus P2A2. So this is the we are just representing this piston over here. This is a P1, pressure 1, acting from this side, and this is the area of the piston of this side, and this is the area of piston from this side. See, the area of this side and this side will be different, because in this side the connecting rod will also have some diameter. Maybe this is very small, but still it will have some diameter. In this side there is no connecting rod. So for example, the diameter of the piston is D, there is a capital D, and if the diameter of the connecting rod from this side, if it is small d, then this side will be, the diameter of this side will be the diameter of piston minus the diameter of connecting rod. So the diameter of this side will be capital D minus small d, and the diameter of from the left side will be simply the capital D. So the area of these two sides of the piston will be different in this way, right? So F of gas will be P1A1 minus P2A2, while A1 I have just told that the area of this side will be pi by 4 capital D square, whereas the area of this side will be pi by 4 capital D square minus small d square, right? Where capital D is the dia of the piston and the small d will be the dia of the connecting rod. So in this way we can find F of gas. Now the second thing is how we can find the inertia force. We know that force is given by mass into acceleration, and in the last video, in the kinematic analysis, we came to know about the formula of acceleration. It is simply r omega square cos theta plus cos 2 theta by n. So in this way we can write inertia force will be equals to mass into acceleration. So if the acceleration is r omega square cos theta plus cos 2 theta by n, so Fi will be m r omega square cos theta plus cos 2 theta by n. So this is how we can find inertia force, and friction force will be simply given in the question. Now the second case is, suppose if the cylinder is given, or in case of the vertical cylinder. So in case of the vertical cylinder, simply the formula will be same, that is f of gas minus fi minus f plus minus mg. So in this vertical cylinder, only plus minus mg is the extra thing. So if for this kind of cylinder, where the force, the F of the gas force, and the mg is always acting in the downward direction, we know that, and the F is acting from behind the cylinder, so if this F and mg is acting at that instant where the F and mg is acting in the same direction, so in this case we will write plus mg. And if the force, like the F of gas and mg, is acting in the opposite direction, we will write minus mg. So only this thing we have to remember in case of the vertical cylinder, that this formula will be same here. The only thing is we have to add or subtract mg. So in this case, where the F and mg is in the same direction, we will add plus mg, and if it is in the opposite direction, we will just subtract m into g, that is mass of the piston into g. We know that it is 8.314, sorry, it will be 9.8, right? So it will be 9.8 Newton per meter square. So we have to remember this thing. Now after finding the piston effort F, we can simply apply geometry and we can find all the other formulas. Like for example, you can remember all these formula, or you can simply remember that diagram and you can find all the other forces. Like Fc will be F by cos beta, and whereas thrust on the cylinder wall, that is Fn, that is Fc sin beta, and we know that Fc equals to F by cos beta into sin beta, that will be F into tan beta. So these are all the important formulas, you have to remember this, or you can just simply remember the diagram. You can find it by applying geometry. The next formula is the crank effort, that is the Ft. Ft equals to Fc sin beta plus theta, and we know that Fc equals to F by cos beta, so the formula will become F sin beta plus theta divided by cos beta. So these are all coming from the geometry, so we have to be very careful. We have to very carefully remember the diagram. Now the next thing is the radial force, that is Fr. Fr is simply Fc cos beta plus theta, and in case of Fc we are writing F by cos beta, so the formula is becoming like this, F cos beta plus theta divided by cos beta. So you can remember all the formula, or I'll suggest you just remember the diagram and the first formula, so you can find all this formula. Yes, and the only the important thing is here, that you will be said to ask the output torque or the turning moment. We know that torque equals to force into radius, so here the torque will be Ft into R, and you know that how to find Ft by the geometry. Again, you will be simply you have to simply multiply it with the radius of the crank. So you can find it from geometry, and you have to you will be given the radius of the crank, and you have to find the torque. Okay, as you can see from the diagram, that this is Ft, okay, which is the crank effort, and if you are asked to find the output torque, you have to simply multiply Ft into R, where R is the crank of the radius, right? So these are the few important formulas you have to remember in order to solve any kind of questions coming in the exam related to the dynamic analysis of single threaded crank mechanism. So thank you for today.